Solve by elimination. 4x minus 5y equals 2, and 5x plus 3y equals 21. Again, we're in a situation where lining them up and adding them together won't result in any cancellation. And we can't just multiply one equation because neither of the coefficients on the variables is a multiple of the other. 5x is not a multiple of 4x, and negative 5y is not a multiple of 3y. So in the end, we're going to have to multiply both of these equations. We could focus on the x's. We've got 4x and 5x, and if we're looking for the smallest multiple of 4 and 5, that's 20, which would work. We can also eliminate the y's. We've got negative 5y and 3y. The smallest multiple of 5 and 3 is 15, so we could try and do that. I'm going to stick with the y's because 15 is smaller than 20, so we'll have smaller numbers. And also, we already have one term that's positive and one term that's negative to help us cancel things out. So if we're going to want to cancel the y's, and we have negative 5y and 3y, what we're going to want, because 15 is a multiple of 3 and 5, we're going to want negative 15y and positive 15y so that the y's cancel. We have the first equation, 4x minus 5y equals 2, and we can turn that negative 5y into a negative 15y by multiplying both sides by 3. So let's do that. When we distribute the 3 on the left, we end up with 12x minus 15y equals 6. Now on the second one, we have 5x plus 3y equals 21. We've got the negative 15y in the other one, so we're going to want to make this one be a positive 15y, and we can turn 3y into 15y by multiplying both sides by 5. When we distribute the 5 on the left, we end up with 25x plus 15y. And when we multiply the right-hand side by 5, 21 times 5 is 105. And now we're in a position where we can stack them and add them because the negative 15y and positive 15y will cancel. So we have 12x minus 15y equals 6. And we've got 25x plus 15y equals 105. Let's add these together. 12x plus 25x is 37x. Negative 15y plus 15y is 0. Those y's cancel. And 105 plus 6 is 111. If we want to get x alone, we have to divide both sides by 37. That leaves us with x on the left. And 111 divided by 37 is precisely 3. So we end up with x equals 3. We also need to solve for y. We do this by substituting x equals 3 into any of the equations with both x and y. I'm going to choose 5x plus 3y equals 21 as the equation that I use for this substitution because the coefficient on y is positive and we want to solve for y, so it makes it a little bit easier. When we substitute in 3 for x, that gives us 5 times 3 plus 3y equals 21. 5 times 3 is 15, so this gives us 15 plus 3y equals 21. If we subtract 15 from both sides, this leaves us with 3y equals 6. And if we divide both sides by 3, that gives us y equals 2. So we have our final answer, x equals 3 and y equals 2.